Namaste. Today's topic is non-homogeneous higher order ordinary differential equation, and today we will have one of the example of a non-homogeneous higher order ordinary differential equation. So this is my one of the example. We need to solve a differential equation y double dash minus 5y dash plus 6y equals to 5 e raised to 4x. Now this is second order ordinary differential equation, as well as this is non-homogeneous because we are having a right hand side function over there. The solution of this differential equation will carry two parts. One of the part will be CF and other part will be PI. Here CF stands for the complementary function, PI stands for the particular integral. So let's solve this differential equation. For the solution, we'll start with its first part, which is CF. For the CF, we need to have its auxiliary equation, and the roots of auxiliary equation will lead us towards the roots of that differential equation, and with the help of that we will able to have its complementary function. So let's start the solution. Solution for this, as we know that this is second order ordinary differential equation, so its general solution will have two arbitrary constants, and both that will be present in CF only. So first of all, we are going for the CF for this differential equation. The provided differential equation is y double dash minus 5y dash plus 6y is equals to 5 e raised to 4x. The decoded form of this equation will be d square y minus 5 dy plus 6y, and our right hand side function is 5 e raised to 4x. Now d square minus 5d plus 6y is equals to 5 e raised to 4x. Now for the auxiliary equation, the form of the auxiliary equation is something like that. Auxiliary equation, it is equals to f of d equals to 0. We need to take f of d equals to 0. We need to compare that term with 0, and by equating that term with 0, we will have d square minus 5d plus 6, and we're going to find its roots of this equation. This is quadratic equation, and the roots of this equation will be d minus 2. Factors of this equation will be d minus 2, d minus 3 will give us the roots 2 and 3. Now both the root of this auxiliary equations are real as well as non-repeated, and we know that the non-repeated real root, how to write the CF for the non-repeated real roots. As per our method, we can write CF. Now we are going to label CF with YC. So our CF will carry two arbitrary constant, that will be C1, C2. C1 for the first root 2, I am mentioning e raised to 2x, and for the second C2 e raised to 3x. This is the way how we are writing a CF for non-repeated real roots, is it? Okay. Now the next part of the solution is YP, which is actually particular integral, and the formula for the yp is yp equals to 1 upon f of d into r of x, 1 upon f of d into r of x. Now we're having f of d as a d square minus 5d plus 6. So d square minus 5d plus 6 will be here. Now what we mean by r of x, our right hand side function provided in the equation, that is 5 times e raised to 4x. So this will act as my r of x. So it is 5 times e raised to 4x. Now how to find p? I have to solve this particular. Okay. For that, as per our shortcut method 1, I need to compare this right hand side function with e raised to x. If I'm going to compare my e raised to 4x with e raised to ax as per our shortcut method 1, now I will have a equals to 4. If I'm going to compare both this, then I will have a equals to 4. So what we are doing in our first shortcut method, we are replacing d with a in this particular term under the condition that the denominator must be non-zero. So right now if I replace d with my a, and right now my a is 4, I'm having a equals to 4, and I'm going to replace d with 4 in the denominator under the condition that denominator must be non-zero. Now one can clearly observe that if I'm replace 4 instead of d here, as 4 is not the root of that quadratic equation, so it will not become 0. So surely I can do that. So just replacing 4 instead of d, I will have 4 the square minus 5 into 4 plus 6. This term will be as it is, 5 times e raised to 4x. Now just simplifying this term, this will gives me 16 minus 20. 16 minus 20 is plus 6. This is 5 times e raised to 4x. So this will be, solving this, 16 plus 6, 22 minus 20, it will be 2, 1 by 2. Multiplying this 5 e raised to 4x with 2 with this, so it will become 5 by 2. Let me write it down once again. So finally my yp will be 5 by 2 e raised to 4x. This will act as my yp, and the general solution for this differential equation will be y equals to yc plus yp, as we know that the general solution is having a formula yc plus yp. So our final answer is y equals to yc, we are having over here c1 e raised to 2x plus c2 e raised to 3x, and my yp is 5 by 2 e raised to 4x. So this is the general solution for the given differential equation. And what to do if our denominator f of d equals to 0 after replacing d with a, that we will discuss in our next video. Thank you.